Yeah, how's everyone doing? Yeah, you know, last night I was thinking, what if there are only 4 people in my room, and I'm still going to put on a great show and smile and talk. This is quite the opposite. So thank you everyone for being here. I'm here to talk about Redis in a multi-tenant environment. So who I am Icha Sethi. I'm a software developer at the Redis team, ObjectRocket Rackspace. I've previously worked on the MySQL product too, so have experiences with operationally running different data stores. Before that, I've been a core contributor on a couple of OpenStack projects, so been in the virtualization fault tolerance domain for a while. So prefacing that, I know the talk says Redis in a multi-tenant environment, but I think this talk applies to any of you, even if you run Redis in-house. Because say you're running microservices, like Chris mentioned this morning in his keynote, or you're running a couple of different applications which use Redis, you should run any data store, or including Redis, in a multi-tenant fashion. Because if say one of your microservices has a bad deploy and brings down Redis, your other parts of your product or other microservices can still be up and running and functioning. So it's extremely important to run everything in a multi-tenancy fashion just to keep your application always up and running and secure. So next question is, why does high availability matter for Redis? Why does all the buzzwords, high availability, fault tolerance, matter for Redis? Redis is a simple process, single process, easy to start up, easy to bring down. My question to you is, how many of you here have done online shopping? Show of hands. Yeah? How many of you are doing online shopping right now? So a couple of you out there might have made impulse buys online. Damn it, I clicked this button too quickly. Amazon makes it too easy, one-click shopping, right? What if the site took a little longer to load? That will give you a couple of seconds to question your decision. So yes, Redis is a simple process. It crashes, you can go in there, investigate and bring it back up and quickly. But the time taken to rebuild your cache is time taken to load your web page or your application. And that's the time you're losing consumers, you're losing revenue, you're giving people a chance to think, did I really need to buy my 5th pair of Nikes, So do I have you all convinced that high availability matters for every data store, including Redis? Yeah? Okay. So I'm going to talk about how at Rackspace we do high availability, fault tolerance for Redis, kind of go into our architecture, security, and details. But at every point I describe what we do, there are takeaways for everyone here. I'm going to try and point out the takeaways as I describe what we do. And if you have any questions, feel free to ask me. So to a customer, we make available the following. So we give them a DNS name, a port, and a password to connect to. If anyone here has used a Redis driver or a client, you know that these are a couple of the important components with helping connection. But if you point this DNS name to a single Redis master, this becomes your point of failure, right? I need to have a hot backup, which is my Redis slave. So hot backup is something which is up and running and easy to switch to, versus a cold backup, which you have to load into memory and start from. So replication is a great way to have a hot backup up and running for you to switch to any time. Now I could have had this DNS name point to my Redis master, have this setup monitored by a Redis Sentinel, and if my master went down, Sentinel would do the switch and promote the Redis slave, and then you could change your DNS name to point to the Redis slave. So what's wrong with this setup? Yeah, time. Good point. So anytime you want to switch what your DNS name is pointing to, the IP, the propagation time is a couple of minutes. So that couple of minutes, you can't make writes, your reads might be corrupt, so you have unpredictable amount of downtime. You do not want that happening. So we didn't want to do that for our customers. You don't want to do that for your application. And we introduced a new layer. So we had the DNS name pointing to a virtual IP, which is the WIP in this diagram. And this whip is associated with HA proxy. So HA proxy is a single process, event-driven. It's written with the philosophies of an operating system in mind. So there's no context switching. It's designed to do data forwarding with minimum CPU and memory. So that means that HA proxy also can talk layer 4 and layer 7 protocol, which makes it amazing. So we use it as a layer 4 protocol, which is the transport layer, to forward our data packets. So are you familiar with HA proxy here to some extent? So I'm going to go into some details then. So we basically point our front end to the virtual IP, the whip, and we point our back end to the Redis master. So anytime there is a failover detected, all you're doing is switching your back end IP over here, and the downtime experience is just detecting that and restarting HA proxy. That's way lesser than disassociating your DNS name with your master IP and associating it with Redis slave. So there's still failure chances here. What's a failure chance here? Yeah, HA proxy. So we've got only one HA proxy running. And that's why we have a hot backup for that too. We have a second LB node, which is running HA proxy with the same configs, and we utilize keep alive D to manage these whips across these two LB nodes. So keep alive D is written in C. It's a routing software. It uses VRRP protocol, and it's again extremely efficient and quick and fast. You can use, so what happens is if we have a notify script in keep alive D, which is basically tracking the health of the whip and your HA proxy, and anytime your LB1 node over here goes down, it moves your whip across to your HA proxy on the other node, thereby, fault tolerance. Your system is self-healing. If you have, again, I'm diving into some more details. If you're aware of keep alive D, there's like unicast protocol and multicast protocol. If we use unicast, and here's the reasoning why. If you're doing a multi-tenant environment, and if your multi-tenant environment is small enough, multicast is going to work for you. But if you have a huge environment with several containers running, you want to think about unicast because there's a config in keep alive D virtual router ID, and that is can be set from 0 to 255. So if you have more than 255 containers, it becomes a problem using multicast in your environment. So that's why we chose to use unicast. So anytime failover happens, at any juncture, it's covered in this architecture. This is how we scale to multiple setups. So I made a cursory mention of Sentinel. So Sentinel is it's done in trees, so it needs quorum. So it's basically pinging your Redis master to say, hey master, ping, are you alive? Can I connect to my Redis? And you can set a config value called down after milliseconds. So if you think your Redis master is unavailable after some time, you could do several triggers. So Sentinel has post hooks you could utilize to do actions on failover. We use global sentinels to monitor our multiple setups. And there's a couple of reasons why we do this. One, we could have run a sentinel inside the Redis master slave, an LB node for each individual HA, which is highly available Redis setup. But then if your Redis slave or master goes down, you're basically losing one of your nodes in your quorum too. So your failure domain becomes twice. So we don't do that. We could have had 3 additional nodes per HA setup to have sentinels run on them. Again, that means you have to spin up 3 additional nodes. So that's additional resources for you if you're running in-house to allocate to Sentinel. Or us as providers, if we did that, we'd have to charge you extra. So we started using global sentinels for monitoring multiple setups. If you are not that large enough, if you're not that large and you have only a couple of setups, you have resources, you could have individual sentinels set up for each HA instance. This is like a brief overview into our control plane, so very, very minimized. So this is similar to what I mentioned before. So we have Redis master, Redis slave, our HA proxy nodes, and we have Sentinel monitoring them. So each of these elements is running in a container on different hosts. So we have minimized the chance for failure on hardware level too. Say you're running this on EC2 nodes. If you're aware of AWS, nodes go missing all the time and they don't even give you warnings. So you don't want to you want to ensure that you're spreading these across different EC2 servers or across different hosts or hardware to minimize your downtime. This is our internal API, Stash and Proxy API, but we use Nova for provisioning our containers. Have you all heard of Nova over here? Okay, so Nova is an OpenStack component. So OpenStack is an open source cloud computing software which has different components, and Nova has logic to do scheduling. So you can say, can you provision me a container which is on a different host as this container? You can give it does capacity management, IP management. You could instead use Docker Swarm or Mesos or Mattercon or look into Nova. So look into something which can help you schedule your containers and do that kind of resource management for you instead of you having to bake in that logic into your application. So kind of control plane. Okay, he was asking me to stay in front of the table. Overview of a control plane. So this architecture offers so many opportunities. Like one thing I briefly spoke about was it makes failover super easy. So our customer is connected to our Edge proxy, our active Edge proxy. And say our Redis master goes down. Sentinel detects it after a couple of pings and the down after milliseconds. And it notifies our APIs, which goes and modifies Edge proxy, which is the backend IP I was talking to you about, and restarts them, and your Edge proxy is now pointing to your Redis master. And the customer has to do nothing at their end. So translate to you running your application, you don't have to change any configs pointing to Redis. You can keep running your application and all this failover happens seamlessly in the background. You can, instead of writing this, we have our APIs and our software making these changes, you could instead use Sentinel post hooks I was talking about. The configs are like notify script and there's a reconfig client script, so these can be triggered on failovers or any specific events in your Sentinel to directly go and modify the configs. So think about, like, if not Edge proxy, what equivalent load balancing or data forwarding software you could use to handle and abstract it away from Redis, your fault tolerance. It makes it really easy to introduce changes. So say I'm a customer or I'm an in-house Redis application, and I started off with 1 gig. My startup blew up or my application blew up. Everyone's clamoring for it. I have a lot of customers. Now I need Redis, which is 5 gigs in size. I cannot afford to bring down my application or change connection strings, copy the data over. How do I do this quickly? So we use some of the internal tools Redis offers us for this. Replication. So we spin up new Redis nodes, which are larger in size. So you spin up your 5 gig nodes. You point your new Redis master to be a slave of your old Redis slave. So replication is activated. And we watch for certain configs. We watch for what's the master link status. Is established? That means is your new Redis master successfully a slave of your old Redis slave. We check for master sync left bytes. So that tells you how many bytes are remaining in this replication process. And we monitored those to wait for replication to have been caught up. So is your new Redis master fairly caught up with your Redis slave? Once that looks good, we make the switch. So in this scenario, the only downtime you're experiencing is restarting Edge proxy, because you've staged your changes at every scenario. You've staged the replication, your data is hot and available and running. Your Edge proxy configs files have been changed, and as soon as you restart, it starts directing traffic to the new Redis master. You have this old setup alive for some time for any remaining traffic to drain through. And once that's done, you delete the old nodes. You have just your new nodes, your bigger nodes available for consumption. So thinking a little bit out of the box, using just replication, we could achieve minimal downtime vertical scaling. You don't always have to go in for clustering, or you might not have the time to think about how do I horizontally scale. You might not have the developer effort or time, but this gives you a good, fairly easy way to scale vertically with minimum downtime and effort. This can also be used for Redis version upgrades. I know there was talk about modules this morning, but that's like the future. So for example, now you're running 2.8.13, you want to switch to, say, 3.2. It's the new latest version. So you could do a very similar replication setup. Just because of backwards incompatibility being there between most versions, you could spin up new nodes with newer versions, replicate your data, and make the switch. So that way you don't have to bring down the node itself. This architecture is, again, I really like this because it's fairly reusable as well. Like I mentioned, I worked on the MySQL team previously, and the MySQL team at Rackspace reuses this architecture for HA-MySQL. So we have a similar master and slave setup. For MySQL, we give different ports for a read and write pool. If it's necessary for you for Redis, you could leverage the same read and write pool with your HA proxy configuration. For Redis, we haven't done it because we haven't found the need or request to do it yet, but you could totally do it if your application demands to do so. So we have the MySQL master, we have the MySQL slaves, you have HA proxy pointing to the master and slaves, but we use a different tool called MHA, which was written by Yoshinori, to do something similar to what Sentinel does, to monitor the health and trigger failover. What this kind of tells you is also, by building this common layer architecture with HA proxy and keep alive D, you could utilize it for beyond Redis in-house. So say a lot of people don't rely on Redis solely as their only data store. They use it in conjunction with other data stores, most likely MySQL or Postgres or something else. So this gives you a good way to combine your multiple data stores and make them highly available by reusing components in your architecture. You might have built in-house expertise in HA proxy and keep alive D in these technologies. It gives you an opportunity to reuse that expertise you built in-house for your other data stores as well, operationally. So the grass is not always green. There are always challenges. And one of the challenges is global sentinels. Any Archer fans here? So ants, what are ants? So we use like 2.8.21 of Sentinel. So we've seen this issue happen often. So say you have a pod, let's call this pod A, and it's added to your global Sentinel. And then you go ahead and delete pod A. And you call the 3 Sentinel nodes individually, tell them, hey, can you delete pod A, can you delete pod A, can you delete pod A? We assume it's deleted. Except that after some time, we see it resurface from the dead. Pod A reappears in the Sentinel configs. If you are using a virtualization technology like Docker or Nova or anything else, you tend to use IP pools and reuse your IPs, especially within your containers, or reuse ports. And reappearance of these configs in your Sentinels means, say, when another pod or and other nodes reuse these IPs, your Sentinel gets really confused. It says, I thought it was a part of pod A, now you're telling me it's a part of pod B, and it tries to connect all the 3. So there are some things we've done to overcome this issue. We have, we try to make, so the calls to Sentinels are asynchronous. You kind of fire and forget. We've done like, once you fire to the Sentinel, we also make additional calls to the Sentinel to make sure it has actually deleted those pods and they haven't come back like the Walking Dead characters. We are also making sure our deletes are really clean. So a lot of times deletes in software industry are like asynchronous options. If any component of your delete fails, you just kind of ignore it. You don't always make your deletes as robust as your creates. So we're making sure that delete actually goes and deletes everything. We're also investigating future possibilities of upgrading Sentinel and testing it out with a newer version to see if that helps solve our problem. So if you've experienced this problem or had luck with it, let me know. So there are some problems within our control, and there are some problems just beyond our control. One of them is the Redis drivers and clients. There are so many of them out here. We have such a rich community. But the problem is every Redis driver or client is written slightly differently. For example, the socket timeout value for like PyRedis might be different from the PHP Redis driver. For example, the connection pooling, the way it's done in Redis might be different from another Java Redis driver. So you as consumers of these Redis clients and Redis drivers should go through the documentation in detail. What are the default values? How can I tweak them? Oh my God, this driver offers retry and disconnect. Totally use that so that your connections, when they error out, you retry your sets and gets and operations. So we have a lot of customers who come to us with issues which have hardly to do with our architecture, but more the way they've configured their clients to talk to our setup. So if you have your application using Redis, evaluate what are the different drivers for Redis. Which of them is the most active in the community? For example, your C# might have a couple of drivers. By Stack Exchange, by a couple of other companies. Go through all of them and evaluate them and see which one offers you most resilience in terms of connection to Redis. I also wanted to sprinkle this presentation with case studies, which is like customer stories, and kind of go into how we overcame some of the issues we saw. So hopefully that helps you if you encounter similar issues. So resize was great. You added it. It was awesome. It worked for us for most of the time, till we experienced a problem. So what tended to happen was we've set up this replication. We see the new Redis master establish connection with the old Redis slave. So it tells it, hey, I want to be your slave. So if you know Redis, understand the internals, what Redis does at this point is it starts preparing an RDB file, which is a backup file, to send the data over to the new slave. So we noticed in the logs it starts to do that, and at some point in time it just says connection lost to slave, and then it would go and clean up the entire setup. We started digging more into this and why this was happening. And it turns out that Redis has a config value, client output buffer limit. Anyone heard of it? Yeah? Experienced issues? Okay, good. So it turns out the client output buffer limit for the slave, though we had configured it fairly largely for that flavor size, for that given customer's data type, so the throughput they were having, they were doing a lot of aggressive writes and a lot of aggressive operations, this couldn't handle it. The config value couldn't handle the limit. So as it was building up the RDB file, it was seeing that this file is larger than the config value for my buffer limit to my slave. And so it would stop replication, and it would never explicitly tell you why it was doing it. So the takeaway for you is, when you set configs for Redis, look at your data type. So it's not only how large your keys are, it's also about your throughput. How often are you writing these keys? So this is a problem not only with resize. So for example, if I decided I want an additional replica in my read pool and another slave, I would have experienced the same problem because my master would have tried to create an RDB file and it would have run into the config limit value again. So in multiple cases you could experience this problem. Other config values for replication I highly encourage you to look into is TCP keep alive. That's important because say if your network, say if your RDB file is taking a lot of time and your slave thinks like my master is not alive, it's going to like disconnect. But this helps you establish that I'm alive through like network without actually sending like Redis communication over. Other one is REPL timeout, which you make sure you set your REPL timeout higher than your REPL slave ping time. So that tells you replication is still, you set your replication time as higher. So don't go by the default values. Your Redis use case is very different from what the default values are sent for. 20 gig Redis is going to be very different from 2 gig Redis. So look at your data set size and throughput and change your, say, replication timeout value. So we have a highly available architecture, which is fault tolerant, fairly self-healing. The next most important thing for a multi-tenant environment is security. Yeah. Like I said at the beginning of the talk, security is really important because you don't want one part of your application affecting another part of your application, or if you have multiple teams using, you don't want one tenant affecting another tenant. You want it to be secure. So say one person gets DDoS, you don't want the other person to be affected. And security and isolation is an important component. Access control levels. There are several ways to do access control levels. We use IP table rules. Old school works excellent. If you want, you could have used also added ACLs to your HA proxy. So there are a couple of reasons we don't do that. One is adding them is you're going to require to either restart or reload HA proxy. That means a blip in connectivity. Don't want that. The other thing is you could have set your ACLs using socket, but then once that doesn't write to disk. So once you reload your config file, you're going to lose all those ACLs in your HA proxy. So IP tables have been a good foolproof way for us to do access control levels. If you have a massive amount of IP table rules, I would say investigate using IP sets. They're supposed to compile the rules and be more efficient. SSL. So last year I was at the Redis Developer Conference Day, so there was a lot of discussion about SSL and Redis. So is Redis designed for performance? Is Redis defined for security? And the answer is obvious. It's defined for performance, to be fast. And any additional layers you add to Redis, like security, you're going to take away some of the performance away from it. And everyone doesn't want that layer of security. So we wanted to provide SSL in a way without affecting Redis performance. We added it externally to a layer with HA proxy and associated our SSL with a different port. So that way, if you are not using SSL, you just have the 6379, which is a standard port, up and always available for you to use. But if you're using SSL, you switch your ports. If you are using SSL in-house or anywhere else with another provider, I would say think about how are you establishing those SSL connections. So SSL connections obviously have a slight overhead. Think about utilizing Redis pipelining or combining multiple commands together or queries together, because that way you don't have to tear up and tear down your session every single time. So that's a pro tip. Containers. I know Docker is the new buzzword now, but we did Docker before, we did containers even before it was cool. We used OVZ 5 years ago, started then. So containers are wonderful. They provide you so much isolation and security. You can limit the number of file descriptors, max connections, your bandwidth, set TC rules, C groups, all at every individual container level. So you're protecting different tenants from each other, you're protecting different services from each other. Containers are the way to go. This is also really useful if you're trying to save money. You know how? So EC2 is expensive too, right? So at any cloud provider, go on Google or anywhere else, or Rackspace, they're expensive. Smaller instances are more expensive. You buy larger instances, you can save more money. So instead of running your processes natively, think about containerizing larger instances to get more bang for your buck. Customer story time. So we had a customer who once filed a ticket saying they cannot access their Redis instance. In-house we have customer data engineers, they all got on the call and they started investigating this issue. First they looked at the individual Redis containers. The individual Redis containers had Redis processes running. It was all fine and green. Then they looked at Sentinels and they saw a couple of failed attempts to failover. They're like, that's strange. Why does Sentinel think Redis is down? It's up and running. Then they looked into the LB nodes. Actually, Proxy was running, but then they saw failed attempts to switch over the VIP, which is the virtual IP between the two nodes. Even stranger. Then they started analyzing the traffic coming in. They did netstat, TCP dump, and all the stuff. And they noticed that this customer was making massive amount of connections and never closing them, and this was exponentially growing. And so what was happening was, since it was using up all these connections, there was no connections left for these, say for the Redis master to reply back to the ping to the Sentinel. There was no way for the Sentinel to ping it, so it thought it was down. There were no connections left for keep alive D to communicate and do failover. And what was great about this, the silver lining in this was none of the other customers, none of the other Redis instances were affected. Each one was protected from the other. So though this particular person experienced downtime, no one else did. This also gave us opportunity to dig in and see, they didn't realize they were making so many connections and scale them down. So when you do this a similar architecture or setup, I would encourage you to think about the following. You can set connection limits or file descriptors or any of those parameters at different levels. You can set them at your proxy container level. You could limit your max clients or connections at your proxy config level. You could limit them at Redis container levels. And finally, you could set the max clients at Redis config level. So at every level, think about how can I isolate and secure my architecture. So connection greater than, for the container greater than proxy, greater than Redis container, greater than Redis master. Kind of like an analogy where you leave some open connections for processes communicating outside. So we've got highly available architecture, we've got security in place, but shit happens, yeah. Things have always gone wrong, we've planned for the best, and that's why you need to monitor your environment. So I think there are 4 questions whenever you decide to monitor something. So what are you going to monitor? How often are you going to do it? Who's going to do it? And what action are you going to take? I'm not going to go into details of the control plane level monitoring we do. I'm going to talk more about Redis specific monitoring because that's what's applicable to this conference. Here are some of the checks, not limited to what we do, but a subset of them. One of my favorites is the front door check. So what we're doing here is we're simulating customer experience. We're doing pings to our Redis instances and seeing, to the VIP, to the DSNS name, and seeing, can I talk to my Redis instance? If yes, great. So this was slightly tricky to implement because we want our architecture to be secure and isolated. So how can I achieve this without impeding security? So we added the IP table rule only for the monitoring one node, which is going to do this check. So think about connection limits, memory usage, all very important to Redis. Some additional ones are like failovers, Redis process down, no valid slaves. How often do I monitor? So every check is going to be different. So like for example, for the front door check, I don't want to bombard my Redis instance, right? It's a customer's instance. You want them to be able to use the connections. And similarly for like failover, I don't want to be pinging and figuring out if a failover occurred. So the Redis, the Sentinel scripts I mentioned about, the triggers, utilize them to say post notifications to your different channels, to your monitoring service saying that, oh, a failover happened. That's a great way to do it. Who does the monitoring? This is completely up to you and your company and your application, how you do it. There's New Relic, Datadog, Sensu, Prometheus, a lot of tools. What do you have expertise for? Have you already paid for a license? All those questions. We use Sensu in-house to do monitoring. And this is like a test environment dashboard we have. So be aware of everything happening everywhere. What are the checks? What looks okay? Be aware of everything. This is an example monitoring alert. So we have this saying that, oh, this pod has a non-responsive master and no promotable slave. So you're knowing that this highly available instance is in a critical state and you need to go look at it. What action is taken? So if you monitor it and do nothing about it, there's no point of monitoring it, right? Yeah. And also, what is the appropriate level of action for each check? For some of the actions you can think about, some of these checks just need monitoring alerts. Some of them you might do Slack integration or HipChat integration into them to ping your channel and alert. Some of them you might want to integrate with your ticketing system and make it like a critical high attention alert. You have an awesome monitoring system, lots of checks, but some of these problems are like you can be overwhelmed by all these checks you have in your environment and no one is taking any action. Again, all the pointers I gave, label your checks, which is actually a critical check, so you can get to pay attention first to those Redis checks. Like max memory, if it's at about 95% memory, you need to jump on it. You need, because soon your customer will no longer be able to access the Redis instance. So, and utilize integrations as well. That's a good way to address issues if no one's paying attention to monitoring it in-house. So customer story. So we did integration into Zendesk. That was one of the alerts we did for the connection limit. So anytime a customer had a very high number of connections, we would trigger a Zendesk ticket. So this tells you critical resource connections on this cluster. So immediately this gives the opportunity for our customer data engineer to go look into it and investigate the instance and approach the customer. Turns out they had rolled out bad code, which was bombarding Redis. And then they realized it and rolled back that code. So this gives you a preemptive chance to roll back before things get too severe. So you rolled out some bad code in-house. This gives you a chance before Redis and your application goes down to realize that, oops, something happened. So that's a great way in which integration helped us be aware of what's happening. So that brings me kind of to the end, wrapping up. So hopefully you got to take away how you can think beyond Redis to make your architecture highly available, secure it, and monitor it. If you have any questions, I think we have a little time, 5 minutes. Yeah? So for that one, we have Sensu deployed on different hosts, and Sensu was checking different connections, containers, and Sensu we had integrated with Zendesk to do the alert. So you write the script. So you can say Sentinel notify on this alert to run this script, and you write the script. Your script can send an alert to Sensu, or it can write to an email or Slack or whatever. Yes?
You mentioned the client buffer.
Yes.
Since you have such a variable environment, and since actually it's supposed to be set, do you automatically scale that up based on like what the throughput is for your clients? Or?
Very good question. That's an active problem we're trying to solve. So what we did is we did some experiments, and we have for every different flavor. Our flavor is a combination of disk and memory. For every memory which we set for the customer, we have the client output buffer limit set to a value, which is kind of proportional to that limit. But we still have encountered some cases where that's not been enough, and we're trying to figure out what's the best way, because we don't analyze customer data, and how do we make that balance of figuring out the right config value. So the question was, have you deployed Redis cluster? No, we've not deployed Redis cluster. So for the use cases we've had, vertical scaling has worked out good enough. So like we've figured out how to do replication, and it's worked out good enough. And we're trying to still, so the Redis clustering is not simple because the logic is in client. We don't want different customers to use only certain clients or certain programming languages. Also, I know there are different proxies available, and we're kind of evaluating them and we're viewing clustering as scaling. It's another form of scaling. So instead of the question being, do you want to cluster or not? The question is, do you want to scale or not? Yes, how do you scale? So that's how we're approaching the problem. So clients are more worried about, do I have enough memory to do my data? They don't really care about the implementation. They want to be able to click a button and say, I want a bigger Redis instance right now. And they like not to worry about where the data lives.
You mentioned hosting Redis with a container.
Yes.
So what container, which product offer that container functionality?
So for containers, we run Nova, and we use a Nova driver, OBZ driver, to do OBZ containers. You could look at Nova or Docker or Mesos. They're all virtualization softwares. Yes.
Yeah, I wanted to touch on partition tolerance. So it seems that we only allow ingress on a single IP, and we can only have a single load balancer directing traffic to Redis, because it has to have a consistent view of what's master and what's not. So have you had experiences with network partitions? And it seems like you can get in a really kind of bad state because you won't be able to be resilient in the face of partitions. I'm wondering if you had experience with that.
So we haven't actually experienced any network partition so far because, like you said, we have only one point of ingress. And so no two sources. So the question was, have you experienced any network partition? So at a given point of time, your virtual IPs can be associated with only one interface. It cannot be associated with two interfaces. So always one node is the master and the other is the backup.
Then I have one follow-up question. So do you allocate resources, like is the load balancer always in the same AC or rack or whatever cloud you're running in? Do you allocate it always in the same network partition, or?
So we make sure they're across different hosts.
Right. Okay.
So yeah. So we don't implement AZs in-house, we do just different hosts.
Okay.
Yeah.
Thank you.
Yes?
Somewhat similar line about online resizes. How do you do it because you don't turn off the AJ proxies, you split it immediately. So what about the location on the master and the rights on the master?
Sure. So the question was, what happens to data consistencies when we do the resize in the architecture described? So it's the best effort minimization. So we wait till we think the master sync progress has completed, and we look for the config values where the bytes remaining is almost 0, and that's when we flip the HA proxy. And what we do is we still allow any remaining data to drain back. So even if there's inconsistency, it's virtually only for a few seconds before we make the flip. And this is way better than, so you balance, right? So either you could bring down your application and then resize and bring it up on a new one. This allows us the flexibility for just a couple of seconds for that to happen. And a lot of times we encourage customers to talk to us when they do resizes, so your application load is low, so that when we actually see that master sync in progress or master sync left bytes is 0, we're not going to get bombarded with a bunch of writes. Yes?
Why don't you simply give a virtual IP to the active master instead of the HA proxy layer? You can maybe get rid of it, but assign the virtual IP to the active master. So why don't you use this? What's the need for HA proxy?
So why don't we give the virtual IP to the most active master?
No, I mean, for each pair of master and slaves,
Yes.
you have a pair of HA proxies.
Yes.
Instead of that layer,
Yes.
just give the virtual IP to the masters.
Yes.
The master is going to slave.
So we would need something still doing that switch, right? So we want, so the benefits of having layers is, so say if your Redis master goes down, one of your keep alive nodes is going down. So one of the resources which is tracking itself is going down. So you're introducing multiple points of failure in the same domain. Okay, so I've been asked to wrap up from the back, but I will be at the Redis booth this afternoon at the ObjectRocket booth. I'm also going to be around the conference. If you want to look for me, red jacket. Welcoming any questions. Thank you, everyone.